Hi, welcome to our webinar. We'll be talking about intelligence at the edge for industrial IoT applications. My name is Joe Sorcelli. I'm a solution architect at AWS and our Global Accounts Division. I work with global customers around the globe for industrial IoT solutions. To start off with, let's do a quick level set. The term Industry 4.0 has been coined to describe today's technology shift. But it's not the first shift that we've experienced in our history. If you look back at the 18th century, we started with mechanical production in our manufacturing facilities using water and steam to power the machinery. As we moved into the 20th century, we started mass producing and manufacturing on supply chains. In the 1970s, we started applying IT concepts to this operational environment. And now today, our technology is permeating all aspects of the ecosystem from end to end. And while cloud is one of the enablers for Industry 4.0, we often think of it as the central enabler that drives and it provides the foundation for these other 8 initiatives. For our purposes, we're going to focus on 2 of these. The first of those is big data and analytics. Our assets and our sensors out in the field are transmitting large volumes of data. We want to ingest all that information and process it and analyze it. In addition, we want to secure that communication, ensure the data is secured, ensure the communication paths are secured. Conceptually, your assets or your things drive your sensors, output information, and really form the foundation for our analytical work. But at an edge location, you might have tens or maybe hundreds of assets. And so that edge location becomes a great aggregation point. You'll ingest data from all of your assets, process it locally, perhaps take some actions locally. Have a dashboard for operational views, provide alerts if data is outside of compliance. But you'll also take the important data and send that to the cloud. And on the cloud, we're going to put that information into a data lake. We're going to use analytical tools to derive intelligence from that data lake. And we'll output that data to machine learning models. While we have many use cases for this information, one of those is around predictive maintenance. Not so long ago, we were able to determine whether an asset was online or offline, perhaps what the last value from a sensor reading was. And that's certainly valuable information. But we'd like to look forward and be able to predict when a part or an asset is going to fail. If you knew all the parts that went into an engine and all those sensors in the engine are giving you information, you should be able to predict in a given 2-week window when a part might fail. And you can pass that information to an operations staff who can then gracefully take that engine out of service, perform the necessary repairs, and put that engine back in service. And while there is downtime associated with that, the alternative can be much worse. Maybe that part fails, or maybe the engine degrades, or maybe the engine stops working altogether. Those unplanned outages are longer to repair and generally more costly to fix. Some of the value that we're going to derive from all this intelligence gives us additional revenue on our top line. Perhaps it gives us a better relationship with our customers, allows us to make better, more intelligent decisions. Perhaps it allows you to sell to your customers an outcome. So instead of selling a service contract for your asset, you sell your customer an outcome, and you guarantee them perhaps 95% availability or 99% efficiencies. and you'll use the data you receive off those assets and our intelligent systems to be able to meet those SLAs. But sometimes the value that we derive is on efficiencies and on a predictive maintenance and the ability to increase the efficiency of our products over time, making better decisions, and in the end, better products. For AWS, we conceptually divide the world into things, those are our assets, they're sensing information, taking action when told to, and the cloud, where we're going to have storage and compute values and analytics. And our goal is to derive intelligence across this end-to-end sequence of entities. Out at your edge, you have things operating. Perhaps they're large assets, power turbines, wind turbines, etc. Perhaps they're small controllers or individual sensors on a light bulb, for example. They're all sending information up to the cloud. And on the cloud side, we want to receive that information securely, route that information to the appropriate end destination, and provide shadow information to determine the current state of that asset or that thing. As you scale, however, the number of things at the edge, oftentimes we want to use an aggregation. And so we have a gateway that we can put out at the edge. It's a microcosm of the cloud connectivity, secure communication, routing of messages, processing of data. And so now your endpoints will talk to your gateways. The gateway will receive that information and send it securely to the cloud. So now you've got hundreds or maybe thousands or tens of thousands of assets in the field. You want to be able to manage and monitor the health of those assets. So we have tools for onboarding assets into your fleet, for searching for data inside those assets, and perhaps importantly, providing software updates over the air. Traditionally, when a customer wanted to go and update software on an asset or a controller, oftentimes that meant sending a human out into the field, plugging in a laptop, plugging in a thumb drive, touching physically the asset in some way. For large enterprise customers, this can add up to tens of thousands of man hours a year. It's highly inefficient. By using software updates over the air, you could update hundreds or even tens of thousands of assets in a matter of minutes. We talked earlier about security. That plays an important role here. You want to be able to secure not only your communications, but secure your fleet. You want to be able to look for anomalies. You want to be able to kick off alerts if you sense an anomaly to determine if that sensor or that asset is going bad, or perhaps you have a security issue you have to take care of. And finally, we want to be able to derive information off all this data. So as the data comes into the cloud, we want to store it in a data store, run analytics on it, and derive intelligence. Additionally, we often want to take that data and input it to a machine learning model such that we can take that information and push it back out to the edge. If we look at the AWS Service Suite for each of these components, out at the edge, we have AWS Greengrass. That's our gateway software that you deploy on your hardware. It provides that secure connectivity to the end devices. Perhaps those are endpoints that are running Amazon FreeRTOS. Perhaps those are larger assets that are using industrial communication protocols like OPC UA. Greengrass has the ability to connect all those devices and aggregate that information. The important data is then sent to the cloud, securely to IoT Core. Rules are built inside IoT Core, and you decide where that data should be further processed. AWS IoT Device Management is what's managing that fleet, providing that software updates over the air. Device Defender is providing our security, our anomaly detection, and our alerting. And then finally, AWS IoT Analytics, receiving that data, storing it into a time series data store, running analytics on it, providing outcomes. So while the service suite at a high level looks quite simple, the reality is much more complex. So here at the edge, we have many different kinds of endpoints. Some running an SDK, communicating to the cloud. Some talking those industrial protocols. Some running Amazon FreeRTOS. We have our gateway device, receiving all this information, processing the messages, perhaps taking some local actions using Lambda. Those messages are then delivered to the cloud. There's our rules engine within IoT Core to be able to route the messages. Within device management, we can search through data. We have those over-the-air updates. Device Defender, mitigating our risk with our anomaly detections. And then analytics on the far side, being able to ingest real-time streaming data into our data store and deriving value. And while this is a microcosm of the complexity of the service set, this is not where the story ends. Information generally flows out of this into enterprise applications. For example, if I was an oil and gas customer, out of my oil rigs, I'm getting information in from drill heads or blowout preventers. And that's being ingested through the Greengrass into IoT analytics. I'm deriving information on that. But then that data further has to go into my enterprise applications. Perhaps I have a large dashboard for an aggregated view. Perhaps I have applications that expose certain data to my third-party customers. Some of that information might also flow into ERP systems that might kick off supply chain activities. So information can flow out of the IoT services into perhaps Amazon Redshift, or to Lambda, or into our machine learning algorithms. So we talked earlier about deriving intelligence. Here's a drill down on how this works. On the left-hand side, you have your assets generating your data, streaming out your values. This is being received at the edge by AWS Greengrass. Maybe it's coming in over one of those industrial protocols. Maybe it's coming in from a device connected with Amazon FreeRTOS. We process the data there. We decide what data is highly valuable based on rules that you configure. And then information is sent up to the cloud, where it's received by IoT Core. Once it's been securely received, we process that data through our rules engine, decide where to send it. In this example, we're sending that information to IoT Analytics. We're ingesting it and storing it, running our analytical models on it. And from there, we have a couple different things we could do. One of those is to provide visualization using Amazon QuickSight to give customers or people in your own enterprise quick access to that data. Perhaps the data that came in is out of compliance. It's above a certain threshold or below a certain threshold. We can raise alarms within IoT Analytics. Many times, that data is moved into Amazon SageMaker, where we can then build and train our machine learning models. Once the model is trained, you build an inference of that model, and we deploy that back out to the edge. So now on AWS Greengrass, our ML inference is able to not only look for information that's out of compliance from the sensors, but also act intelligently as data is received. and be able to make split-second decisions on changing the operation of the asset. But this is a long cycle. As new data is received, it flows in through the core, into analytics, updates the machine learning models, new inference is pushed down to the edge. And over time, we develop a smarter ecosystem. So why is AWS a good place to do industrial IoT? In the first place, we have many reference architectures available for industry verticals. I referenced oil and gas earlier. Perhaps you're in the energy sector or aerospace or manufacturing. You can find a unique reference architecture for your industry to get started quickly. The breadth and depth of our services allows you to gather data, run your analytics, and take critical actions, whether those devices are at the edge or up in the cloud. Of course, we reference security. That's a critical job, day zero job for AWS. So we secure our communications. We have authentication and authorization mechanisms to ensure your solution is secure. Scalability is an important concept. The solutions scale to billions of devices and trillions of messages. Our analytics and machine learning algorithms allow you to train your models and deploy those references out to the edge, allow you to take split-second decisions. Many IoT solutions involve multiple partners. And so we have a rich ecosystem of technology and consulting partners to allow you to build your solution. And finally, we have many industrial customers, some that I work with personally, that have derived great business value from these solutions. It allows them to drive efficiencies. It allows them to sell outcomes to their customers. It allows them to deliver solutions to the market at a much more rapid pace. So at this time, we'd like to show a demo of Greengrass and IoT Analytics in action. I'd like to introduce Jan Metzner, a solution architect here at AWS. We're going to show you a controller, a valve connecting over an OT network into Greengrass. We're going to use some protocol adapters. We're going to aggregate data. We're going to send that data to IoT Core, into IoT Analytics, and then pass it on to SageMaker to do some anomaly detection. Jan, take it away.
My name is Jan Metzner. I'm a special solutions architect for IoT with AWS. So I have prepared a demo where we see Greengrass and AWS IoT Analytics in action. So the demo looks a little bit similar to the picture you've seen before. You see a back-off PLC. We see also a gateway, and you see the power supply, obviously, and you see the different networks. Obviously, the OT network is a little bit small. Yes, it's just the gray cable, but this is the connection from the gateway to the PLC itself. In a real network, obviously, there's a switch in between. And then you see the yellow cable, which is the connectivity to the internet. So on the yellow cable, we have the connectivity to AWS IoT Core, and we have Greengrass running on the industrial PC. So the left-hand side, the PLC is the standard back-off PLC, and the right-hand side is a standard IPC. This is also a back-off IPC, but it could be any system that can run a Linux operating system with the requirements which you have on our website. So let's look into this. We have the management console itself. I have prepared Greengrass on the gateway already. If you have never seen how to configure Greengrass, I will not go through this, but we will see how to deploy the Lambda functions itself. So Greengrass itself, as I said before, you deploy Lambda functions, and the Lambda functions have the ability to run as a process in order to connect to other systems and provide other functionality. So how do we connect to a PLC that provides an OPC UA server? We have a sample Lambda function for that. And if you look on AWS Labs, you will find this. It is also linked in our Greengrass documentation. So what do we need to do is actually, we need to connect, first of all, we need to connect with an OPC UA browser and need to know, okay, which values are interesting, which are provided by the PLC. And for that, we need to obviously have the IP address. So you see, this is the private IP address from the PLC itself, and already got some interesting values. So there's a simulation running on the PLC, which is providing valve data. So the duration of the closing of the valve and the pressure of the valve. And this is provided for 4 different valves itself on the PLC. So this is baked into a Lambda function, and we can deploy this Lambda function to Greengrass. So let's quickly do that. So I have the Lambda function already uploaded. So let's this one here. Deploy that. I mean to wire this app. This is just the deployment. We configure this a little bit in order to make that work and make this a long-running Lambda function. So just for testing, I will forward all the data from this Lambda function to the cloud so that we see what's going on and what the Lambda function is actually exposing. It will actually subscribe to the properties that I've shown you, and will forward all the messages just outgoing once there's an update. So let's deploy this one here. I've already subscribed well, let me just double check that I have a current connection. So we subscribe to OPC UA, and oops, we have already values. So this, you see, these are the values from the different valves. Let's subscribe just to one of the valves. Well, you see it already. You see that for each valve we have different measurements, and each measurement will come in as a separate event. So this is running inside the Greengrass environment here, and we just forward all the data to the cloud. Since we are actually interested in the values from a single valve, but all the values, it is actually easy with this microservice environment to just combine the values into a single message. So how do we do that? Obviously, we have a Lambda function for this, and I've written a small Lambda function. This is just combining the data from each same entity. So it splits actually the ID of the event, and we'll just combine all the data from one valve, and once the data is complete, it will just publish the data on the specified topic. So let's subscribe to this one here, and obviously beforehand we should also deploy this Lambda function. So let's deploy this here. So this is also already here installed. We have the initial version. And we'll forward the data from the protocol converter, so from the OPC UA protocol converter to the combine events Lambda function. We'll just forward all the events here. And then again, we want to forward only those events to the cloud itself. So we do here, from this Lambda function, we will forward the data that the Lambda function is outputting to the cloud itself. So let's quickly deploy this and see what's happening. So still the the data from the OPC UA devices will go on. So once this is already deployed, deployment is there, we see that we now have a combined data. So we have for each valve, let me just pause this for a second. For a single valve, we have both the duration and the pressure. Now what we can do now is we can forward the data to IoT Analytics. For this, we go to IoT Analytics and we can just create a channel. We read messages from this topic. We'll just use so we have a channel created. So this channel will store the data. We'll then actually the channel will get the data and will store the data through a pipeline. The pipeline could actually modify the data and combine the data, can actually execute also Lambda functions. So it's quite helpful to really combine the events and maybe even enrich the events. Let's just store all our input and create a new data store. And use this one as an output. So this was all I needed to do in order to get the data and store the data. So what happens now is that the data is produced on the PLC. It is forwarded to Greengrass. Each data point is combined. A single message for each valve is forwarded to AWS IoT. AWS IoT will put this into a channel, and the channel is read out by the pipeline, and then it's stored in a data store. So I already built that beforehand. So we have a gateway data store here. And now we can analyze this. The easiest way to analyze this is to create a data set. A data set is a SQL query on top of a data store where we can actually then extract the data and store it inside a data set. So the easiest way to do that is to select a data store and select everything. You can even select windows so that you have just a sliding window. At the moment, we just do this in this way, and you can schedule how often this query is run. We'll just do this manually and create a data set. And with this, actually, we are able to load the data from this data set. And you see that it is just a simple query. In order to reduce the time here, I will just show you how it looks like once this is filled. So for example, if you want to have all the data from a specific device, you see that you can just select where the ID is, the valve ID, and you see you have already the values, the duration and the pressure, you have a timestamp and so on and so forth. Now we want to actually analyze this. And the easiest way to do that is to just look into this. AWS IoT Analytics provides notebooks and integrations to Amazon SageMaker. So we will just create a sample notebook. There are samples for this, and we'll just take the anomaly detection notebook. We use the data source. Let's take the Delta data source. This is similar. It's just a little bit smaller, the data set. And we will use the webinar notebook instance, which I created beforehand. So this actually pushes the notebook into the instance, and we'll just open this one here. In the meantime, let's just look into this data set. Should have actually content here. Okay, let's see if this is working. So the only thing what you need to do is here, this, if you have not seen that before, it's a notebook where you can actually run machine learning and analytics code inside Python on the server side. And this is a sample notebook which has both documentation but also the code included, and you can just execute this out of the box. The only thing what we need to change here is to have the time column. This is a timestamp, and we use the pressure. I think it was pressure. Let's take the duration, which we want to analyze. We store this, and we'll just execute this now. So this just loads the matplot libraries. So this configures the data set. We now do a connection to the data set. Okay, so something as obviously in the demo, I checked everything before, but it was not, something is not getting data in there. Then let's take the data set that I already prepared beforehand, which is this one here, which has data in there. And now I know what's going on. Okay, sorry for that. We'll use a different notebook. This one here. I created a fresh SageMaker instance, but I forgot to get permissions to access IoT Analytics, and in this way it was not able to connect to AWS IoT Analytics to get the data. So that's why I will load the ready-made notebook that I prepared before. So it takes some time because now the data set is a little bit bigger. So it will get all the data and run this. So we run an anomaly detection algorithm. This is ready-made inside AWS IoT Analytics, so you can just open your console and look at this one. And in the last step, we actually do the analysis and plot the result itself. So let's look into this. The simulation actually opens and closes the valve with different pressures. And you see the actual value is a small blue line here. So this one. And we see the red dots the anomalies that were detected by this algorithm. So this is just a simple example how easy you can get data from an industrial machine, store it, and do a quick look into the data, as well as analyzing the data with ready-made notebooks from IoT Analytics. So obviously, it doesn't stop here. You have seen beforehand, once we create the data set itself, we can also create a container container that is executed once we have a new data in the data set itself, which means we can run those analyses continuously. And for example, if we detect something like an anomaly, maybe we need to tweak this a little bit because we have a lot of anomalies, but if we do this in the right way, we can, for example, directly do alerting and also have a dashboard where you can see those results.
Jan, thank you very much. At this time, we'd like to take some questions from the audience.